So good afternoon, everyone. On behalf of IEEE Kerala chapter, I welcome you all to the sixth Power Talk hosted by IEEE Kerala chapter. So here we have Ms. Priyadarshini T from College of Engineering Chengannur to present her talk on audio spotlight. So I welcome Ms. Priyadarshini T to start the session.
Good evening to all. Have you ever imagined something that creates focused beams of sound similar to light beams, such as a flashlight or laser light? What about a flash sound? That's pretty interesting, right? So that's what our today's topic is, audio spotlighting. Before moving into our topic, let me introduce myself. I am Priyadarshini T, pursuing my Bachelor's of Technology in Electronics and Communication Engineering at College of Engineering, Chengannur. So now let's move on to audio spotlighting. These are the points that we will be covering today. First, we will discuss a brief introduction to audio spotlight. Then we'll move on to an overview of the technology behind it, its working, architecture, advantages and disadvantages, and conclude by viewing its applications and scope. So, what an audio spotlight is? It is a directional source of audio sound created using a parametric array. That is, it generates a sound beam that is much narrower than the sound beam generated by a conventional source. It uses a combination of some nonlinear acoustics and some fancy mathematics. In simple terms, by shining sound to a particular location, specific listeners can be targeted with sound without others nearby hearing it. That is to focus sound into a highly directional. The figure depicts what actually an audio spotlight is. The beam sound to our specific listeners and preserve the quiet as it is. Before moving further, let's discuss some basic concepts related to sound. All sound are produced by vibration. The sound of our voices is the result of vocal cords vibrating in our throat, while sound from a plucked guitar string comes from vibration of the string. The number of vibration an object make while it's making a sound is called frequency, as we all know is measured in hertz. Sound waves humans can hear have a frequency limit of 20,000 hertz to down 20 hertz. Any higher than that and the sound becomes ultrasonic, inaudible to our ears. The cones of larger loudspeakers used in traditional public address systems vibrate more slowly, making them better suited for sounds in the range of human hearing. Audio spotlight uses this ultrasonic directional beam of sound. How is this highly directional beam of sound created? Audio spotlight exploits the property of non-linearity of air and uses ultrasonic energy to focus the sound wave. The ultrasonic sound waves are actually breaked into lower frequency, that is audible sound waves. So these ultrasound waves can travel along a narrow path. People to the left or to the right of the target remain silent. Don't be confused. After moving on to further slides, you'll get a brief idea of what it actually is. Joseph Pompey Holosonic Research Labs in 1998 invented the audio spotlight that is made of a sound processor, amplifier, and the transducer that reduced audible distortion. Now let's move on to the technology. As we have discussed, audible sound coming from a large loudspeaker has much more wavelength ranging from a few inches to several feet, making it easier for sound to travel in all directions. Ultrasound, on the other hand, comes from much smaller sources and therefore has much smaller wavelength, usually only a few millimeters long. In other words, ultrasound essentially travels in a very narrow beam, thus makes it easy for focusing the waves towards a desired area. The figure depicts the difference between a regular speaker and a parametric speaker. That is, a parametric speaker has much lower wavelength compared to our regular speakers. Loudspeakers with large aperture size is used to produce this kind of a signal. As the beam moves through the air, gradual distortion takes place in a predictable way. This gives rise to audible components that can be accurately predicted and precisely controlled. Now let's move on to its working. About half a dozen commonly used speaker types are in general use today. The audible portions of sounds tend to spread out in all directions from the point of origin. Here, the original low frequency sound is transformed into a higher frequency ultrasound by applying it to an audio spotlight emitter device. This device converts our sound to a low frequency sound. Since the wavelength is small, the sound beam will be very narrow. Due to its nonlinearity property, the air slightly alters the sound wave, giving rise to a new sound wave within the ultrasonic wave. This is the new sound wave which is produced, which is a replica of our original sound waves with higher frequency. This information signal is in human audible frequency range. Since we can't hear the ultrasound waves, we hear only this new wave which is formed. The beam angle will be around 3 degree, and as a result the sound beam will will be narrow with a smaller dispersion. Now let's see what constitutes this audio spotlight device. The components of audio spotlight system include power supply, frequency oscillator, modulator, audio signal processor, microcontroller, ultrasonic amplifier, and transducer. Let's discuss one by one. First one is power supply. Like all electronics, the audio spotlight works off the DC supply. Ultrasonic amplifier requires 48-volt DC supply for its working and low voltage for microcontroller and other units. The frequency oscillator generates ultrasonic frequency in the range of which is required for the modulation of information signal. Now, in order to convert the source signal material into an ultrasonic signal, a modulation scheme is required which is achieved through a modulator. In addition, error correction is needed to reduce distortion without loss of efficiency. By using a DSP modulator, the modulation index can be reduced to decrease the distortion. The audio signal is sent to electronic signal processing circuit where equalization and distortion control are performed in order to produce a good quality sound signal. The next most important component of audio spotlighting system is the microcontroller. A dedicated microcontroller circuit takes care of the functional management of the system. In the future version, it is expected that the whole process like the functional management, signal processing, double sideband modulation, and even switched power supply would be effectively taken care of by a single embedded IC chip, that is our microcontroller. A high-frequency ultrasonic power amplifier amplifies this frequency-modulated wave in order to match the impedance of the integrated transducer so that the output will be more powerful and can cover more distance. The transducer that we are using here is 1.27 centimeter thick and 17 centimeter in diameter. It is capable of producing audibility up to 200 meters with better clarity of sound. It has the ability of real-time sound reproduction with zero lag. It can be wall, overhead, or flash mounted. These transducers are arranged in the form of an array which is called parametric array. Here is the block diagram of the audio spotlight system. Here's the power supply, the microcontroller that takes care of the functional management of the system, the different transducers, amplifier for amplification of signal, etc. Here's a comparison of our audio spotlight system with a conventional loudspeaker. That is, in a conventional loudspeaker, it produces a high or large range of wavelength, while in audio spotlight, the wavelength is very small with higher frequency. It inherits the non-linearity property of air for this demodulation process. It has much sharper directivity than conventional loudspeakers. Now, this sound that reaches the human ear through two different methods. They are the modes of listening. Direct audio can direct sound at a specific target, creating contained area of listening space, while projected audio can bounce off a sound object, creating an audio image which gives the illusion of a loudspeaker, which the listener perceives as the source of a sound. Direct mode requires a clear line of approach from the sound system unit to the point where the listener can hear the audio. To restrict the audio in a specific area, this method is very appropriate. Now, projected or virtual mode requires an unbroken line of approach from the emitter of audio spotlighting system. So the emitter is pointed at the spot where the sound is to be heard. For this mode of operation, the sound beam from an emitter is made to reflect from a reflecting surface such as a wall or diffuser surface, etc. A virtual sound source creates an illusion of sound source that emanates from a surface or direction where no physical loudspeaker is present. That is, the information is said to a large number of people. As we all know, everything in this universe has its own pros and cons. Let's move on to the good and bad sides of audio spotlighting system. Talking about its advantages, ultrasonic emitter devices are thin and flat and do not require a mounting cabinet. This can they can focus sound only at a place you want and can preserve this um, silent people. They focus or directed source travels much faster in a straight line than conventional loudspeakers. The dispersion can be controlled and it requires only small power as required for our usually speakers. There's no lag in reproducing the sound and it is portable. The disadvantages that we are facing is it's highly costly. It can be misused by enemies. Both speakers and amplifiers are separate here and the maintenance is very high. Audio Spotlight is actually a real boon to the future with wide range of amazing applications, such as in automobiles, in advertisements for safety officials, for military applications, etc. In automobiles, beam alert signals can be directly propagated from an announcement device in the dashboard to the driver. Recently, Mercedes-Benz are fitted with audio spotlighting speakers so that individual travelers can enjoy the music of their own interest. The targeted or directed audio technology is going to a huge commercial markets right now. It provides targeted advertisements directly at the point of purchase, which is very creative and interesting. Now, for safety officials, portable audio spotlighting devices are used for communicating with a specific person in a crowd of different people. In case of museums, audio spotlight can be used to describe about a particular object to a particular person standing in front of it, so that the other person standing in front of some different other objects will not be able to hear this description. In case of entertainment systems, in home theater systems, real Rear speakers can be eliminated by the implementation of audio spotlighting, and the properties of sound can be improved. Also, ship-to-ship communications and shipboard announcements in case of military applications. It is also used in emergency rescue system for communication with endangered people far from reach. In audio or video conferencing, etc., this audio spotlighting is very applicable. Audio spotlighting really puts sound wherever you want it and holds the promise of replacing these conventional loudspeakers. It allows the user to control the direction of propagation of sound. Now, I'm concluding by saying that audio spotlighting is going to change our view in sound transmission system. The user can decide the direction of sound in which it should propagate. Since the sound in this system propagates in single direction, it is applicable in several fields. Audio spotlighting will be an extraordinary experience for the users and will serve our ears with magical experience. So that's all about audio spotlight. Any doubts? Uh, I guess there's no doubt. So can we stop?
So, dear participants, if you have any doubt, just unmute your mic and you can ask any doubts you can.
So I guess there's no doubt. So I thank IEEE Kerala PS chapter for giving me such an opportunity to learn something new and to share it with all other friends. So thank you. Thank you each and everyone for the support and coordination. Thank you all. Always happy to learn.
Okay, so thank you, Priyadarshini, for taking the power talks on audio spotlighting. I also thank all the participants. So thank you all.